A question like this builds off of what we learned yesterday. First, notice this is a calculator OK question. Then that you're given the derivative, and we're looking for A, F to obtain a relative minimum. So that means when our derivative, F prime, is going from negative to positive. So we're looking for that 0, likely, critical point, where the derivative goes from negative to positive, and then increasing, that would be looking at the derivative, and we would want our derivative to be positive. So the portion above the x-axis. So that's what we're looking for. So all we're going to do is graph on our calculator and use what we've learned about finding zeros to find these locations. So I'm going to go to my calculator. I've already put this in to save time. Now I'm going to go to my window. The problem statement said from -2 to 2 on that interval. So my x min will be -2, my x max will be 2. Because the amplitude of sine and cosine is 1, going from -2 to 2 is plenty to show everything. So I'll graph it. So we need to find these zeros, or at least, we need to find both zeros. Second, trace, calculate a 0. My left bound can be -2, and my right bound can be 0, let's say. And it finds that first one at -6.47. It looks like there's symmetry here, so the other one's probably the same on the positive side, but we'll find it. Second, trace a 0. Now I can make my left bound 0 and my right bound over at 2. My guess will find, sure enough, it was symmetric, 1.647. So again, this is the graph of our derivative f prime, where we're going from negative to positive on our derivative is 1.647, so that would be our minimum. X equals 1.647. Let's practice justifying our answer. We would say where f prime of x changes from negative to positive, and then the increasing part is where our f prime is greater than 0. So that's this green section and this green section. So on the interval -2 to 2, we would say -2, -1.647, union 1.647 to 2, and our justification, f prime of x is greater than 0 on these intervals.